Today's video is brought to you by Pokemon. There he is. And this was requested, just so you know. Alright, today's video is 8-4, Angles of Elevation and Depression. And this is just another opportunity for you to learn a little bit better the trigonometry ratios and how to use them. So make sure you have your trig table with you. Your graphic organizer, the example 3 and 4 can go on the bottom of your page, but you can leave some space there. You're going to write very little at the top, and then we're going to go over 4 examples. We're going to start with some vocabulary. The first 2 things that I'd like you to remember are these key words, angle of elevation and angle of depression. An angle of elevation is the angle above a horizontal line, and the angle of depression, it's the angle below a horizontal line. Let me give you an example. Suppose it says a dog looks up at his owner from an angle of elevation of 58 degrees. And this is what you should be imagining. Here's a dog, that's a dog. Here's the horizontal line, and an angle of elevation is looking up. That means that this is 58 degrees right here. And this is the owner. I better draw that more like a dog, huh? All right, I'm going to leave that like that. I can't make it better. The angle of depression, here's an example of that one. A bird looks down at a picnic from a tree with an angle of depression of 34 degrees. Okay, let me see if I can draw this one. So imagine you have a tree, and there's a bird in there. Okay, that's a bird. And the bird is looking down. Now, here is the horizontal line here, and he's looking down with an angle of depression of 34 degrees at a picnic. Here's a picnic basket. Okay. So keep these in mind as we go through a couple word problems. Before we get started, I want you to go ahead and copy down example 1 and example 2 right above example 3 and 4. When you're ready, unpause and we'll go through all 4 examples. Let's start with example 1. Here's what it says. Pokemon is looking up at a tree with an angle of elevation of 31 degrees. If the tree is 10 feet tall, how far is the tree away from his pointy ears? Okay, the first thing I want to do is draw a picture here. I know that he is looking up at the tree, and that the tree is 10 feet tall, and I know that that's going to create a right angle right there. They're saying that it's an angle of elevation of 31 degrees, and they're asking how far is it away from his pointy ears. Now, I did a bad job saying this. I promise any questions on tests will be better than this. What I was asking is, really, is how far is this distance right here? So this is my question. What's that length right there? So from there, what we're going to do is we're going to look at our angle and ask ourselves which of the trig functions we'll be using. Now with this angle, this side would be opposite, and this side over here is the hypotenuse. Opposite and hypotenuse, that means we're dealing with sine. So the sine of 31 degrees is equal to the opposite length, 10, over the hypotenuse, which is x. Now our goal is to solve for x, so I'll start by multiplying by x on both sides. When I do that, I bring my x out of the denominator and get 10 equals x times the sine of 31 degrees. We're almost there. To get the x alone now, I'm going to divide by the sine of 31 degrees on both sides. And from here, I'm almost to my answer. X is 10 divided by the sine of 31 degrees. At this point, I'm going to look at my trig table and I'm going to find 31. 31 degrees is right here. And the sine is in the first column, so it's 0.5150. Now I want to show you a little trick here because I know you guys aren't a fan of dividing. This is the same as 10 divided by 0.515. Now if there's a 0 as the last number, you don't need to write it. That means that when I do my division of 10 divided by 0.515, I have one less decimal to worry about. 1, 2, 3. So now I'm just asking myself, how many times does 515 fit into 10,000? Now I know that 515 fits into 1,000 one time. So that's 515. I subtract, and I get 485 when I bring down my 0. 515 fits into 4,859 times, forgot my decimal point up there, and 9 times 515 is 4,635. When I subtract that, I get 215, and I bring down my 0. 515 fits into 2,115 4 times. 4 times 515 is 2,060. When I subtract that, I just am left with 90. That's a 90. And I bring down my 0. 515 fits into 900 just one time, with a remainder, when I subtract that, of 385. Now for all of these, it doesn't specify where I'd like you to round, so for all of them, I would like you to round to the nearest tenth. Nearest tenth. That means that my x value is 19.41 approximately. I'm going to round to the nearest tenth and see if my 1 affects my 4, which it doesn't. So my answer is the distance to Pokemon's ears to the tree is 19.4 feet.